Hi everybody. So part A, give the formulas for first order Taylor series approximation for an arbitrary map, f from Rn to Rm, using three different notations. And those notations are here, here, and here. And so we have to fill in for these dot dot dots. What do the dot dot dots become? Okay, so the first thing is, this is a new word that we haven't seen before, but it exactly means linearization. It's the same thing, and it exactly means the linear approximation. In other words, it's the exact same formula we've seen. Now we've seen it in this second format. And so right away I can just write f of x plus v is about equal to f of x. And then I have to change it a little bit, and what I add is the derivative of f at the point x applied to the movement vector v. Okay, and so if I'm visualizing this, I'd have to choose some input and output space. And so I'll just choose mapping R2 to R3. And if I'm at some point x, then f of x is somewhere. And then if I move by a vector v, I'm at this new point, x plus v. And so then the real value of that point is somewhere, and my approximation is close. And what is this vector? This vector is the derivative of f at the point x applied to v, outputting a change in output vector. This will be my change in the output to linear first order. Okay, we call it first order because we're taking the first derivative, and Taylor series is what you have seen in single variable calculus, where it starts with f of x and then f prime of x and then f double prime of x. And for linearization, for linear approximation, for first order, we don't do the second derivative or third derivative. We just use the first derivative. Okay, let's choose a different notation. F of y is approximately equal to f of x. So now I'm looking here, and I have to decide what is dot dot dot. How do I replace dot dot dot? So I'll first do a picture in order to help me. Now, I'm starting at f of x, apparently, and I need to probably change it. So maybe there's x. And what if here's y? Okay, and then in my output space, somewhere is f of x. And somewhere else is f of y, the actual value of f of y. And so this vector here, this vector is the vector, well, final minus initial is how we create a vector. And so it's the vector y minus x. And so my approximation will apply the derivative of f at the point x, applied to what vector? Y minus x. And so that's what I fill in here. df at the point x applied to the vector y minus x. And that makes this formula say exactly the same thing as that formula. Okay? They just named things a little differently. Okay? So y is x plus v. V is y minus x. The last one looks like this. You'll see this often as well. The point of this problem is to make sure that in any of the forms you see it, you know what to do. And so let's see what should go for dot 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 there. So I'll first copy the formula at the beginning of it. And now I need to know, what do I add? Well, in order to do that, I should draw a picture to help me get started. So I'm somewhere at x, and then my output is f of x in the output space. Maybe it's three-dimensional again. This is just a cartoon, so. And now I've probably, this is what I'm plugging in, so this must be an input. Whatever this is, it has to be an input. So it must be somewhere in the input space. How about there? And then I see that, okay, the only thing that makes sense is for this, this triangle x to be a vector. So triangle x must be a vector. That is the only thing that makes sense, is for triangle x to be a vector. And what we say is we say delta x, and it means a movement in x, a change in x. And for some reason, people use delta for change. And so this vector here is the vector delta x. It has two symbols in its name, but it's still one vector. Okay. And so then we'll use that vector to produce a new vector. Now what is this vector? It will be the derivative of f at the point x applied to the vector delta x. Okay, and somewhere is the true f of x plus delta x. The true output value is maybe over here, but we will get close. And that actually completes parts A and parts B. I've given essentially 3 ways to write the exact same formula. It is a linear approximation. It is also called a linearization. It is also called a first-order Taylor series approximation. And then I've drawn pictures to help me figure out what do these symbols mean. What do the symbols mean?